Okay, so we should all be on page 15, all right? Again, one more time just to remind you, I need you guys to get 3-ring binders for the simple reason that everything we do is hole punched, and you need to be able to open and close and insert things, because I hate using these pages in the book. We don't use them all the time. Sometimes we do, sometimes we don't. Sometimes I give you another page of notes that we write on. But I'm going to be giving it to you with hole punches, so you're going to want to open and put it in. So please get a 3-ring binder or talk to me if you're having trouble getting that. Okay, so linear and nonlinear. On Friday, we talked a little bit about linear. It's a line. It's a straight line. So what we're doing today is looking at some graphs and some equations and saying, is it linear or not linear? Kind of a basic concept, but really, really important concept, okay? So let me read a little bit to you here. In a linear function, no variable is raised to a power other than 1. That is key. Raised to a power of 1 for linear. Any linear function can be written in the form f of x equals mx plus b. If you guys remember, that's slope-intercept form. Okay, so slope-intercept form, and we're going to work on graphing in slope-intercept form tomorrow as a review, okay? One more thing, we talked about it Friday, but f of x can also mean, you could have g of x, h of x, any letter in the alphabet. What does it actually represent, though? Y. Yep, it's y equals mx plus b. You'll see me write y, you'll see me write f of x, you'll see me write g of x. We do that a lot. Okay. This is also a linear equation in this form. It's called standard form, but it doesn't matter what order it's in, honestly, as long as the x is to the power of 1. And if you don't see an exponent, it means it's a 1, okay? If there's any other number there, it's not. Okay, so that's basically what I want you to take out of there. So I don't like the way they did example 1, so I'm going to give us some examples up here. So example 1, which is going to match your homework, determine whether each function is linear. Okay, so you're basically saying yes or no. Yes or no, is it linear? So let's do some examples. So if I gave you I want you guys to be able to look at that and just by looking, say yes or no. So yes or no? Yes. How do we know? Exponent of 1 on the x. X to the first power. If you don't see a number there, it is 1. That means it's linear. Okay? Let's try another one. Linear or not? No. There is an x to the first, but there's also an x to the second. The minute you see that, we say, no, not linear. This would not make a line, okay, if we graphed it. Let me try and trick you. What if I gave you, this is a kind of a trick question. Not really, but what do we think? Yes? Why? What is it? You were right. Don't go with your gut. You said, yeah. I gave you volume 2. I'm so sorry. I didn't even know I had volume 2. So sorry. I mean, why is linear? It makes it. What type of line is that, Mish? Do they know? What type? Horizontal. It makes a horizontal line. Yeah. So listen, a number that doesn't have a letter next to it is called a constant. 3 is a constant. This is linear. It would make a horizontal line at y equals 3. Okay? That's the graph of it. Yeah. Yeah. I'm gonna teach you all about these calculators. All right. Since you asked, guys, look. On that calculator, on your calculator, go to the y equals button at top left. Okay? If there's anything there, you can hit clear. Like I have a 3 there, I'm just gonna hit clear. And type any of these in. Let's do that first one. Let's do this one. Let's do this. Let's type in, so you have a y there. Let's do 2x minus 1. So I'm going to just type in 2. Here's your X button. Look, everybody, right here. Hit the X right there. It's next to alpha. 2x minus 1. So once you have it there, if you hit the graph button, it'll graph it for you. You could also see what the table of values are. You can find all the ordered pairs. Look, look, look. See where it says table? It's in blue, so I have to hit the second button, graph, and there's your table of values, all your X, Y values, the ordered pairs that make up that line. No. Okay. Yours isn't work. It's not turning on? Okay. Look on with her and I'll come help you. Shane, look at your neighbors and I'll change it. Okay. So listen, we're going to go deep into how to do these calculators later. But since you asked, I thought I'd just show you that. Okay, one more. No. Okay, so super simple concept, right? All you're looking for is that the biggest exponent is 1. Must be a 1. If there's any other power other than 1, it's a no. And then the exception to the rules, if it's just a plain number called a constant, we would say that's a horizontal line. But you also saw how you can check it on your calculators now. Okay, so first concept, just by looking at the equation, is it a line or not? Okay? All right. Turn it over to example 2. These are pretty easy as well. Visually, looking at a graph, is it a line or not? I mean, I don't know if this needs much instruction. Is this a line? No. So they're calling it nonlinear. This is called an absolute value function. It's made up of pieces of lines, like segments, but it's not a line, okay? And of course this is, okay? So we now have 2 different ways to tell whether it's linear, and that's looking at it visually, the picture of the equation, which is called a graph, and then of course the algebraic version of it, which is the equation, okay? We're skipping example 3 if you want to cross it out. On to example 4. Stay with me. This is why I hate using the book for the notes. The only time I really use the book for the notes is when there's graphs, because it's just hard to recreate them, so I like to use them and I just adapt it. Okay, let's talk about example 4 and 5. We're going to kind of do those together. What we're talking about now is intercepts, okay? Intercepts is where a graph crosses or touches one of the axes. So axis, plural, is axes. So an x-intercept is where a point at which the graph of a function intersects an axis is called an intercept. So an x-intercept is the x-coordinate of a point where the graph crosses the x-axis. And of course, we can say the same thing for the y-intercept is the y-coordinate of a point where the graph crosses the y-axis. So this, again, is just visual. It's being able to look at the graph and tell me where the line or the graph touches each axis, okay? Think about intercept in football. So if I'm the quarterback throwing to a receiver and someone crosses that path and grabs the ball out of my path, they're intercepting the ball, okay? So that's kind of like where that idea comes from. So looking at this line, of course, this is linear. The graph intersects the x-axis at 0, 0. So the x-intercept is 0, okay? This is a pretty dumb example, if you ask me, because the y-intercept is also 0, 0, so the y-intercept is 0. Can they be the same? Of course. There's an example of that, okay? Yeah. Yes, thank you for telling me. I used to have my desk like over there tilted so I could see both of these, and then I wanted to be more part of the group. I wanted to be part of your little crowd. So I moved over here, and now I have to keep looking over my shoulder. So please don't be shy about telling me if you can't see it well. Better now? Yeah, okay, thanks for letting me know. Okay, so let's talk about So this is a nonlinear, right? Nonlinear, you can look at that and say it's nonlinear. It still has intercepts. It just might have more than one. Okay, with a line, you'll only have one x-intercept and one y-intercept. But with nonlinears, you could have more than one. So they listed them here for us. The graph intersects the x-axis at those points, at -3, 0, -1, 0, and 2, 0. So what we would say is the x-intercepts are the x values, and sometimes some books I've taught out of, they have you write the whole ordered pair. They're asking us just to put the x value. Okay, so just those are my x-intercepts. Notice there's 3 of them here. Where does the graph intercept approximately? Notice how it's counting. This is important. Look at the graph. As we go up, they only gave us 2 numbers. If this is 8 and this is 16, what are we counting by though? What would this first line be? 4. Yeah. So this is 4, 8, and so on. So if this is 8, I heard somebody say it, this would be 12. So where's the 0 go? The beginning, okay? So something to just kind of get in your brain so that you're really clear on it is anytime we're talking about an x-intercept, the y value is 0. And anytime we're talking about the y-intercept, the x value is 0, okay? Please take a second and see if you can get these. We have a linear and a nonlinear. Try it, try it. Try them. I'll reveal the answer in a moment. Check and see if you got them right. Good? Do we get it? Any questions? Yeah? You're good? So, moral of the story, we learned on that last problem, make sure you see what they're counting by. So, one more thing, and then I'm going to give you your homework. You'll finish it in class. On this last graph that we did up here, the reason they gave us those numbers is because they changed it. If you don't see any writing on an X or Y axis, that means you're counting by 1, okay? Your intervals, it's called, are 1. So unless you saw them putting like a 4 here, you'd have to figure out what they're counting by. Otherwise, you always know it's counting by 1, okay? All right, so here's your homework, classwork, whatever. Page 21 and 22. Guys, really important today, make sure you label it A2. Okay, all of my homework has to be labeled A1. Friday was A1, today is A2, tomorrow will be A3. That's really, really important. I would write it at the top of that page, know where it is. When it comes time for homework checks, you have to be organized. Yep. So, here, I wrote it here too. It's right here. It's the same thing. I just wrote it there too. I number my assignments, like Friday was A1, today's A2. When it comes time for me to check homework, I don't check every homework. I'll say, okay, guys, I'm going to check A2 and A5. And you'll flip to them, and I just check them. A is just, and then second quarter I do B, then C, and then D. It's just a way for me to kind of keep things organized. Instead of like, open to page 11, da-da-da-da. It's just a very simple way. On Friday? Mm-hmm. Yeah. So remember, guys, if you are not here, you're going to Canvas to get the lesson. I'll come and talk to you about that. All right? Now listen. I'm going to put the key up, but I don't want you just copying it. I want you to try, okay? I put the key up so you can check your answers. I also put it on Canvas, so if you're absent, you can always check your answers, or if you don't finish, you could check Canvas and get it there. But I'm going to. Yeah, I'm going to. But please don't just sit there and copy it, okay? Because there's really no work to show on today's. It's just yes or no's pretty much, and like naming the numbers. So try and then check answers, okay? So remember, this is just yes or no. You don't have to justify your answer. The way I do things in the notes is how I want you to do it in the homework. So I'm going to so you're saying yes or no if these are linear.